to talk about acceleration, acceleration is a rate of change of velocity or speed. So to talk about acceleration, we're first going to need to talk about rates of change. So let's talk in a more simple thing that we all understand, like cookies. I like cookies, everyone likes cookies, so let's talk about cookies. If you have 12 cookies and you bake some cookies, and now you have 23 cookies, how many cookies did we change? Now most of you can look at this right away and say, oh, we changed 11 cookies. But we need to look at what math is behind that, because that's going to be the same math that's behind our acceleration. So let's do it this way. If you have 23 cookies that you ended with, okay, let's write that down. 23 cookies. Now, if you're asking how many you changed, you wouldn't say you changed 23 cookies because you started with some cookies, right? So you have to take those off of the cookies you ended with, because those didn't take part in the change. So 12 cookies we started with did not take part in the change. So let's subtract those 12 cookies we started with, and all you're going to be left with is the cookies that changed. Alright? So 23 minus 12, 11 cookies is how much we changed. Alright? So what we need to know now is a little bit of some words or terminology. So what we started with is right here. So I'm going to say start, but there's another word that scientists have for this. We say initial. It's similar to the word initiate, okay? So initiate means to start. Initial is the starting. It's another word for starting, okay? And this is how many cookies we ended with. Scientists like to call this final. So for cookies, the way you'd note this is C for cookies, F for final, minus C for cookies, I for initial, is equal to change in cookies, okay? Scientists also use this triangle that means change. This triangle is the Greek letter delta, it means change. So, even if that didn't make sense, what we need to know is that you take the final cookies, CF, which is what you ended with, and the initial cookies, CI, which is what you started with. If you subtract the ones you started with, because they didn't take part in the change, all you're left with is the cookies that changed, that you gained to get to this point. Alright, so if you wanted to talk about change in velocity is going to be velocity final minus velocity initial is equal to change in velocity. So we're saying, how much velocity did you end with? Let's take away what we already had at the beginning, and then we'll know how much it changed between these two. So velocity final, what you ended with, minus velocity initial is going to give us change in velocity. Okay, so now the question is, how quickly is that changing? So if you, let's say, went back to the cookies example, and what if I was able to bake these cookies, all these cookies, in 1 hour? Okay, so let's say that this process all took 1 hour. The way we're going to write this is to find rate of cookie baking. It's going to be cookies final minus cookies initial, which, what is that? Remember? That's just the change in cookies. We're going to take our change in cookies and we need to divide by how long it took us, how much time it took us to bake those cookies, 1 hour, to show a rate of change. Okay? Let's do 1 hour, which is time to bake. Okay? Cookies final minus cookies initial. We have 23 minus 12, it's 11 over 1 hour. And our ending answer, since we're dividing by hours by 1 hour, it's going to be 11 cookies per hour. Okay? So if that makes sense, if you continued along that rate of change, you'd get 11 cookies every hour. All right. So now let's talk about change of velocity over time. That's what acceleration is. So let's bring that right over here. Let's say an object such as a skateboarder, say a skater goes from 2 meters per second to 5 meters per second in, let's say, 1.5 seconds. What is his acceleration, or that means change in speed over time? Okay, what's his acceleration? Well, if we follow the same model, acceleration is going to be equal to the velocity final minus the velocity initial, all that over time. Because we're saying how much did he change his speed or velocity over a certain amount of time, right? So now let's put those numbers in. Okay? So what was his final speed? That was 5 meters per second, right? Subtract what was his initial speed, 2 meters per second. How long did it take him to increase that much in speed? That was 1.5 seconds. 5 minus 2 is 3. 3 divided by 1.5 is 2. So it's 2 meters over seconds, but all of that is over seconds, right? Because that seconds on the bottom. We have meters per second and seconds on the bottom. Another way to write that is 2 meters per second squared. So what we're saying is every 1 second, which is right here, the skater gains 2 meters per second of speed. So this is a good explanation of how we use acceleration. It can be used in many different ways, but you will always be given one of these 4 different things that you can find in the question and then solve for the last one, acceleration, velocity final, velocity initial, or time. You might be asked to solve for any of those. But that's a good explanation of acceleration.